This is an exciting theorem that you're going to learn in calculus class. It's called the Squeeze Theorem, and it's actually used to solve this particular limit. The Squeeze Theorem tells us that if two functions share the same limit at a specific point, and if we can somehow prove that these two functions squeeze a third function in the middle, then that function also shares that limit. But my goal today is to give you a geometric approach to this particular limit. Make sure you show this to your calculus teacher. If we're trying to find this limit right here, we're going to refer to the unit circle. We have a particular sector here with some radian theta. First, we're going to go ahead and draw a right triangle that has a base of cosine and a height of sine theta. You can quickly see this through SOHCAHTOA. Great, so we have this right triangle. Now let's go ahead and focus on the sector here formed by the angle theta. And now we're going to extend this radius so that it touches a vertical line perpendicular to the x-axis. Now this is also a right triangle, and keep in mind this length on the bottom is 1, so this height through SOHCAHTOA is actually tan theta. And visually you can see the first triangle is less than or equal to the sector, which is less than or equal to the larger triangle. So let's talk about their areas. The first triangle has an area of base, which is cosine, times the height, which is sine divided by 2. Using area of a sector with radius 1, we can see that the area of this is just theta over 2. And the third triangle has a base of 1 and a height of tangent, so that gives us an area of tangent theta over 2. Let's just go ahead and multiply the cosine to everything here. And you know what? Let's just go ahead and rewrite this tangent into sine theta over cosine theta. Let's go ahead and divide everything by sine. I made a small mistake here on the left, I fixed that, but oh boy, look at the function that we have right in the middle. It sort of looks like the limit that we were trying to find, doesn't it? So now let's just go ahead and flip these and give the reciprocal of them, which essentially gives us the same thing, but we just have to flip our inequalities. And now for the grand finale, let's take the limit as theta approaches 0. And as I do this, just know that we're about to perform something called direct substitution, where you simply plug in 0 in for theta on the functions to the left and right. Cosine of 0 is 1, so this gives us 1. We don't know what the limit on the middle is because that's what we're trying to prove. And on the right hand side, cosine of 0 is 1, so we have 1 as well. Giving us two functions where the limit is 1, we prove that these functions squeeze this function in the middle, so this limit also has to equal to 1. And that's the Squeeze Theorem, which I obviously spelled incorrectly.